Welcome everybody to this topic of statistics, recognizing variables in hypothesis testing. As we know, hypothesis testing, the traditional method, has 6 steps, and each of the steps, um, you need to be able to recognize the variables used for all these steps, and they're all given to you in the exercises. So it's very important to figure out, what they're giving you. Especially for step 5, that's when we do the math. We calculate the test statistics, and you have most of the variables all together for the formula. Now, for step 3, when you decide whether you're doing the Z or the T distribution, and this is already a video on its own, just as a reminder, if you have the population standard deviation, then you are going to use your Z for your critical value, and you will calculate the Z of your sample. If you do not have the population standard deviation, but you have the sample standard deviation S, then you will use the T statistic. So step 5, you will calculate the T, and you will get your critical value for T on step 3. So all of this, what is T, what is X, what is mu, what is N, what is S, there's a lot of different letters. So let's see what they mean. X is your sample mean. Simple mean. Both formulas here have the X hat. The simple mean. Hypothesis testing is somebody or yourself are wondering if the population has changed. If something like you got new materials, you got new machines, you hire new people, something is new, and you're trying to see if the population behavior has changed. Is the mean different? So in order to validate whether things are the same or they've changed, you go and take a sample, and you will get a sample mean, your X hat. Okay. Now, when you're doing hypothesis testing, you will see whether the mean has changed or not, or if it's more than or less than. This mu is your population mean. Okay. Then, from step 3, you will figure out whether they're giving you the population standard deviation, which is your sigma. And if they're giving you sigma, the population standard deviation, then you know that you will have to use Z. And if they're giving you the simple standard deviation, then that is S. And if they're giving you S, then you need to be looking at the T distribution. Either way, you will always get a sample, so you will have a sample size. Sample size is in both equations, and each exercise will also tell you the level of significance, the alpha. Alpha is the area of rejection, the area of your tails. Rejection, yeah, the area of the tail. And then from step 4, you will figure out if you have one tail that is upper or lower, or 2 tails. So the alpha is the area where you're rejecting H0. You're always testing for H0. So I will give you the same exercise, but 2 different wordings, so that in hopes that you can figure out when they're giving you sigma, the population standard deviation, or they're giving you the sample standard deviation, and how to recognize all the variables. So let's see. A food company claims that the average spending for daily food per person is greater than 32 dirhams in the UAE. So this is the average, so this is a mean for everybody in the UAE. So everybody is population mean, and that is 32 dirhams. And here they're giving you the keywords of greater than. So when you do, when you're trying to figure out where you're testing, your greater than is your upper tail. Your H1 will be mu more than 32. And since this is greater than, then your H0 is mu less than and equal to 32. All right, so we know greater than is upper tail. This is your alpha. A random sample of 100 consumers is randomly selected for the survey. So you're going to go and test 100 people. That's your N. The simple mean of this 100 people, the simple mean is found to be 33.02. So this is your sample mean. The population standard deviation is 6.75. This is your sigma, population standard deviation. Test the claim at a 0.05 significance level. This is your alpha. So the area here for rejection is alpha equals to 0.05, which means the other side is 1 minus alpha, 1 minus 0.05. This area here is 0.95. From here, you know that the tail area you will reject H0, and the opposite side, because they're mutually, they're collectively exhaustive. So the upper side you will not reject H0. Now let's go see what we do with all of these variables. So since we know that they've given us the population standard deviation, we will calculate for Z. Okay, population mean was given to us at 33.02. Population mean 32, so this is your sample mean. This is your population mean. All right, sigma, population standard deviation 6.775, and our n equals to 100. So when you do the Z is equal to 1.51. So this is just when you calculate the Z. Step 3, you figure out that you're using the Z. Step 5 is when you do the test statistics, you actually calculate it. So let's see how this looks in MegaStat. Okay, oops, let me get out from here. Now, for MegaStat, you do data MegaStat, okay, and you do hypothesis testing, mean versus hypothesized value. Here you have two choices. You have either data input or summary input. Data input is if you had the information from the 100 people, like if you went and you had the answer from the survey of the 100 people, and you had a big column of the 100 data points. We don't have that. What we have is called the summary input. For the summary input, MegaStat requires us to do select range, and here you see on the bold label that came out, select range with label, mean, SD, and N. So what is this? What are they telling us to do? So ideally, you will have this already written, and you do input range, you click on it, and you select. So before we continue, let me cancel out of this and tell you what that is. So before you go into MegaStat to do hypothesis testing, if you have a summary input, you need to have these 4 cells here. Okay, let me change the color from green to blue. You need to have these 4 cells. A label, which is here, I'm telling you what is on the column. You do not need to have this, but I suggest you stop this video here and you copy this in your own Excel, and then you save it, and you save it as a chapter 10 template. Oops, sorry. Yes, because you will need this for every single chapter 10 exercise or hypothesis testing exercise. Okay, so now you technically only need this 4. Everything else is labeling, but labeling will help you not get confused. So what MegaStat needs is this 4. The first one is a label, any word, literally anything. You can put your name if you want to. In here, I'm typing step 5, just to give it a label. Why does it need it? You know, it needs to have some sort of title on it. So put any word, but it needs it. If you do not highlight from here down, if you only do the 3 numbers, it will not work. You need to have a label, some title. Then it needs to have, in this particular order, the first one was any label. Okay, the next one, it needs to have the sample mean. It just is mean, but it requires the sample mean, your X hat. Okay, which in this case is 33.02. The next one, it needs SD. It said SD, standard deviation, whether it's S or sigma. Whatever your standard deviation is, that's the next number that needs to be down in Excel. And the last one, it needs the sample size, the N. So these are the 4 numbers that are absolutely needed to do hypothesis testing in MegaStat. 4 of them, including the label. Please do not just highlight this 3. You need the label. All right. Then the next 3 numbers are not needed. You can type them directly, but I suggest you write them down to not get confused. Your population mean, which in MegaStat shows as hypothesized mean. That's what it shows on your window says hypothesized mean, that refers to the population mean, your mu. In this exercise is 32. Then MegaStat will ask you for the confidence. The confidence is your 1 minus alpha. So I wrote alpha here. The window in MegaStat does not ask you for alpha, it asks you for 1 minus alpha. Alpha is your significance level, which in this exercise is 0.05. So alpha just calls for your confidence, which is 1 minus alpha. In this Excel, I have written here as a formula 1 minus, I did 1 minus, and B6 is the alpha, 0.05. So as I type alpha, let's say I type an alpha of 0.02, then my confidence level is 0.98. Let's see that my alpha is 0.07. Then, oops, I'm sorry. You see I put 2 zeros, I'm sorry, 2 decimal places, so obviously Excel does not know what that means. So let's say the alpha is 0.07, here we go. Then your confidence is 1 minus alpha, which is 0.93. So I put a formula here. This one here is equals 1 minus alpha. The one before is my alpha. So I've written a formula. It's absolutely up to you, but this is what you need every time. So if you can put this in your own Excel and save it for your own guidance, I think it will be best. All right, so let's go and do our exercise in MegaStat. This is information from the exercise. So data, MegaStat, hypothesis testing, means versus hypothesize. And we're doing summary input. Summary input requires a label, a mean, standard deviation, and n. So click on input range and highlight your 4 cells that have the label, simple mean, your standard deviation, whether it's sigma or s, and your sample size. Then, hypothesize mean. Here you can type the population mean, 32, or if you have it in here, just click on it. Either way is fine. The next step is for you to, are you doing the t-test or the z-test? Now, we were given the standard deviation of the population, so is z. And then here, alternative, what is your H1? Greater than, not equal to, or less than? The keyword in the exercise was greater than. And here is the confidence, which is 1 minus alpha. 1 minus alpha, our alpha was 0.05, so is 95%. Here you choose. Let's say here I never changed the level from, if alpha was 0.07, for example, and the confidence level was then 0.93, 0.93 is not one of the choices. If you have a confidence level that is not part of the choices, then you type it, okay? Filter out and do 93. In this case, from the one in the exercise is 95% because it's alpha of 0.05. You press OK, and we get here. Let me get this a little bit bigger. I'm sorry, I have other past information here. Okay, wait. I'm sorry. So let me come back in here again, and let me make this a little bigger and find it now. Here we go. This is information. So what we find here is the Z of 1.51, and we have our, in here, the hypothesized mean is the mu, sample mean for step 5, this is the label that we gave it, this is our x hat, standard deviation was our sigma, n is our 100, standard error is always equal to the sample or population standard deviation divided by the square root of n. Since they gave us sigma, this is what the standard error is. Okay, so we come here, and this is where we get our z equals to 1.51. So now, same information, but a couple of words are different, and let's see how this is going to affect the math that we do. Let's see. A food company claims that the average spending for daily food per person is greater than 32 dirhams in the UAE. So we're still talking about a 32 dirhams as a population mean. A random sample of 100 consumers is randomly selected for the survey. Simple mean is 33.02 with a standard deviation of 6.75. So this is where the difference is. The line starts here. The simple mean is 33.02. The standard deviation of the simple is 6.75. Test the claim at an alpha of 0.05. Okay, so in here, they never told us that the simple standard deviation was 6.75. The line starts here. These whole two lines are about the simple. So your simple mean is 33.02. The simple standard deviation is 0.675. So the simple standard deviation, you use t, okay, which when you do the math is the same. You get the same 1.51. But when you do your step 3, when you do your critical value, when you separate, here we know that we do greater than, so your alpha is at the top. But since they've given you S, then you need to get your critical value for T. So your critical value of T is what's different. Your step 5 is the same number. Now, when you do it in MegaStat, let me show you, in MegaStat how it will be different. This is our information from MegaStat. As I mentioned to you, save this as a template. You do data MegaStat, and in this particular exercise, again, we highlight the first 4 sections. Hypothesize mean, you either type 32 or you click on it. But here, this in the bottom, you're doing the t-test. You're doing again greater than, and you're doing a confidence level of 95. So t-test versus z-test. Now, I will say okay, and you will see that the math is absolutely the same. Oops, here is absolutely the same. Your p-value is not. It was 0.606 for this one, and it was 0.0654 if you were using the Z value, and 0.067 if you were using the p-value for T. So that's different. But if you're doing the traditional value, this is your test statistic is the same. Okay, and that wraps up, ladies and gentlemen. Figuring out your variables for hypothesis testing for this particular topic. Hope this helps. Have a great day, and thank you, everybody.